So this one is January 2017 paper, Unit 2. The first question, which of the following type of wave can be used in fiber optic or optical fiber? So which radiation or which type of wave we are using in fiber optic or optical fiber? For microwaves are used for satellite communication. Radio waves are used for land communication or terrestrial communication, like on the land if you want to transfer electromagnetic radiation. Ultrasound are not used for the communication purpose. It's just for detection. So what we are left with, infrared. So either infrared or visible light can be used because it can easily undergo total internal reflection. Because in fiber optic or optical fiber, we need lights like electromagnetic radiation. Ultrasound is not electromagnetic, it is mechanical. In question 2, in a piano, a note is produced by striking a stretch wire with a hammer. Which of the following describe the wave produced? So example, a note is produced by striking a stretch wire. So there's a stretch wire. And when the hammer strikes the stretch wire, as a result, what it produces a pattern like this. Actually, why this pattern is produced? Because what happened when the hammer strike the metal wire, like the red metal wire here. So as a result, two waves travel in opposite direction. When they strike, they bounce back. As a result, these two waves will combine with each other. As a result of a combination of two waves traveling in opposite direction, what we'll get a standing wave, or we can also say stationary wave. So it cannot be longitudinal. Why it cannot be longitudinal? Because when we strike the wire, the particles vibrate up and down, and the direction of the wave is either towards the right or the left hand side. So it cannot be longitudinal. Either it is transverse, so either progressive or stationary. What kind of wave? Because wave produced in a string, wave produced in a pipe, that is by combination of two or more waves which are traveling in opposite direction. That's why whenever two waves traveling in opposite direction, it always gives rise to what? It gives rise to stationary or a standing wave. That's why D is the right answer for this. In question 3, which of the following would improve the level of a detail in ultrasound scan? So if we want, like example, more particles from which the ultrasound or the wave reflect. So the wave which we are using, the pulse, we should reduce the length of the pulse, because after completing after completing one cycle, the part of the pulse is reflected. So if you are using a shorter pulse, means a shorter wavelength or length of a pulse is small, then we'll get a more detailed image. So how to reduce the length of the pulse? By reducing a wavelength. And how we can reduce a wavelength? By increasing a frequency. So increase the duration of the pulses, that won't affect the detailed image. Increasing a frequency. So when we increase the frequency, what will happen? The wavelength will decrease. So length of the pulse will be shorter. The size of the pulse is shorter. So more points from which the pulse will be reflected, because after completing each cycle, the part of the pulse is reflected. So once it completed one cycle, if the frequency is high or wavelength is shorter, so the part of the pulse will reflect and will get more detailed image. Increasing a time interval between the pulses, that does not affect the detail of image, and increasing a wavelength will reduce the detail of the image. So changing the time interval does not affect on the detail of the image. Only the frequency or wavelength can affect the detail of the image. And how to improve that detail of the image? By reducing a pulse length, so that we'll get more points from which the pulse is reflected. The next question, question 4. The diagram shows a ray of a light in medium 1 strike a boundary with medium 2. Medium 1, the light frequency is f1 and the wavelength is lambda 1. In medium 2, the light has a frequency f2 and the wavelength is lambda 2. Which of the following is necessary for a total internal reflection to occur? Look, whenever light travels from rarer to denser or denser to rarer, so it does not, the frequency of a light does not change at all. Like frequency, what frequency is here, same frequency should be here. But what about the second part? That when light, because in a total internal reflection, the light should travel from denser to rarer medium. So this should be a denser. And here is a rarer medium, like low density. Light should strike a denser to rarer boundary. So because in a denser medium, the light is traveling slower. So we have the formula V equals F lambda. So frequency should be equal to V divided by lambda. So if the speed is slower, the wavelength should also be smaller so that the ratio won't change. Same thing what happened, because in air, like it should be strike from denser to rarer boundary. In a rarer medium, the wave will travel faster. As a result, it will travel faster, so speed is more. So if speed is more, it will have a greater wavelength. But the ratio between the speed and the wavelength should be constant. So when it is in a denser medium, the wavelength is shorter, speed is also slower. But in a rarer medium, speed is faster and the wavelength is also greater. So what is necessary, which wavelength? Like when we say this is lambda 1 and here is lambda 2. So lambda 1 should be smaller and lambda 2 should be greater. So lambda 2 should be more than lambda 1. So idea is that for a total internal reflection to occur, the light must travel, like must strike denser to rarer boundary. Another question, a source of EMF which is having no internal resistance. So there is no internal resistance connected across a negative temperature coefficient thermistor. Negative temperature coefficient thermistor means that the temperature and resistance are inversely proportional. The current in the thermistor and the potential across the thermistor is measured. So we measure the voltage and current. The temperature of a thermistor increase. Which of the following would we observe? Because when we increase the temperature, its resistance will decrease. As the resistance decreases, what is the relation between resistance and current? If resistance decreases for the component, the current will increase. So first option, there's a decrease in current. That is wrong. There's a decrease in potential. We are applying a potential, so we don't observe it. Like what potential we applied? If we have a thermistor connected to a battery or a cell, we connect a voltmeter and we connect an ammeter. What about the resistance? Resistance is voltage divided by current. Voltage, what voltage we applied, same voltage will be there. It does not depend on what is our temperature. So voltage does not change. But what about current? Because if we increase the temperature, resistance of a thermistor will be low. So if the resistance of thermistor is low, the current in the thermistor will increase. So option C is the right answer. So potential does not change because that is what we applied. Only what happened, the current changes as the resistance of a thermistor changes. Then which of the following equation does not include a SI based quantity? So here time is SI based quantity. Here also time and current SI based quantity. Voltage current, because voltage and resistance are not SI, but current is a SI. There are 7 fundamental quantities. Here work done or energy, charge and voltage, none of them is SI based quantity. That's why D is the right answer. Only the SI based quantity, there are 7, which are length, mass, time, temperature, amount of substance, light intensity. And electric current as well. The diagram shows a ray of a light passing from which is passing from glass to water. So which of the following is a correct expression for a refractive index passing from glass to water? So how to work out the expression for the refractive index? First thing, we need angle of incidence and angle of reflection. So when I draw the normal is always perpendicular to surface. So what is this angle? This will be 90 minus y. The total 90, like this total is 90, and if we subtract y, so angle of incidence is 90 minus y. And what about angle of refraction? Again, angle between the normal and the surface is 90, and this part is x, so it will be 90 minus x. So this one is 90 minus x. So angles will be 90 minus y or 90 minus x. Then it is traveling from, as they mentioned here in the question, that it is traveling from glass to water. And which of the following is the correct expression for refractive index for a light passing from glass to water? So we have the Snell's law. What is the Snell's law? It states n1 sine theta 1 equals n2 sine theta 2. So this is the refractive index of the glass, and this one has a refractive index for water. So when we solve, like example, refractive index, which of the following expression refractive index for a light from glass to water? So medium 1 is a glass, medium 2 is a water. So refractive index of a glass example n1, and sine angle of incidence is 90 minus y equal n2 sine, and what about theta 2? It is 90 minus x. So when we work out, if you remember, because it is the refractive index moving from glass, the question is it is moving from glass to water. So means when we are working out the refractive index, the second medium is the water, the first medium is the glass. So we want a ratio between n2 or n1. Because from medium 2 to divided by medium 1, when we simplify, so this will be sine, because n1 moved there, so this is sine 90 minus y divided by sine 90 minus x. So n2 over n1 is actually the ratio between the two refractive index when the light is moving from glass to water. Or you can also use a formula. There's also, whenever, as you can see, it is bending away from the normal. So glass is a dense medium, and this one is a rarer medium. And refractive index for a medium, when it is traveling from more dense to less dense, so it is sine angle R the simple formula for refractive index, that is equals to sine angle I over sine angle R. The angle of incidence divided by angle of refraction will also give us the refractive index. So why it is first numerator 90 minus y and denominator 90 minus x? Because this will give us a refractive index when it is traveling from glass to water, the ratio between them. Always use the Snell's law, like the medium 2 divided by medium 1 equal to sine angle I over sine angle R. In question 8, a water wave meet a small gap in a barrier. Which of the following table correctly describe the speed and the wavelength of the water after passing through a gap? So speed and the wavelength, because speed changes if there's a refraction. In refraction, speed and wavelength changes, otherwise it does not. So that's why there will be no change in the speed and there will be no change in the wavelength as well. This is happening in refraction, but here this is a diffraction. In diffraction, it just only changes the direction, or you can also say intensity. In question 9, the wavelength of a progressive wave is defined as the distance between the adjacent point. So if you have a progressive wave, how we define the term wavelength? Progressive wave means the wave which can travel from one place to another. We call that as a progressive wave. So what is the wavelength? Wavelength is the distance between two identical points, or 2 points which are in phase. Like crest and crest, these are in phase, trough and trough in phase, or from the one mean position to another mean position. So distance between two successive crests or two successive troughs. And we can also say distance between the in-phase points. So they have the same displacement? No. Same amplitude? No. Actually, it is a distance between the 2 points which are in phase. So when 2 points are in phase, the distance between them is known as the wavelength. So this is a wavelength. This one is also a wavelength. Then in question 10, a potential is applied across a sample of a metal wire. So there is a current in the wire. The charge carrier in the wire have a drift velocity V. Without changing the applied potential across a second identical wire which is placed in parallel the first wire. What is the drift velocity? So how we compare the drift velocity? As the potential is applied across a sample of a metal wire, so there's a current in the wire, and the charge carrier in the wire have a drift velocity V. So we did not change the potential, we did not change. A second identical wire is placed. And we apply the same voltage. So when identical wires are there, example, if we were having only a single resistor, single wire is there, consider as a resistor. So the current I is there. Resistance is R and the drift velocity is V. And the voltage which we applied, the drift velocity is V and the voltage applied capital V. Now what happened when two identical wires are connected in parallel with each other? So the combined resistance of a circuit will decrease because it is a product. The combined resistance will be the product of the two. So the product divided by sum. So R multiplied by R divided by R. So when we multiply, it will be R square divided by 2R. So when we simplify, it will be R by 2. Means the total circuit resistance will be half. If total circuit resistance is half, what will be the current coming out from the battery? That will be twice. But that current, because these are identical resistors, so they will receive the same current. So if the current, because total current which is coming from the battery become twice, but the current in each branch is I. So as a result, what happens if the current does not change? What will be the drift velocity? As drift velocity is given by a formula, I is equals to N A Q V. So N is the number of charge carrier. That depends on the material. They did not change. They mentioned it is identical. So that does not change. A is the area, because identical means that does not change. Q is the charge of electron, which is constant. So it means the current and drift velocity are directly proportional. So if the current in the component does not change, so what happened to drift velocity? That also does not change. That's why B is the right answer for this.